Welcome back to DBAJUNCTION, where we simplify Oracle technologies with real-world experience. Let's start with today's agenda.
Today we'll explore Oracle SQL Firewall, understand its architecture, learn capture and enforcement modes, and finish with a live demonstration.
Next, we'll configure Oracle SQL Firewall, capture trusted SQL activity, generate the allow list. Authorized SQL can be detected and blocked in real time.
So, what is Oracle SQL Firewall? Think of it as a security guard inside your Oracle database. It learns which SQL statements are trusted and monitors all incoming SQL activity. Now that we understand how it works, we're ready to move on to the configuration phase. We'll start by identifying trusted traffic, creating our allow list, and finally enabling enforcement mode. Let's dive in.
Let's get started. Before proceeding further, let's first verify the current database version to avoid any confusion and confirm that we are indeed working with Oracle AI Database 26ai. For this, we'll query the $instance dynamic performance view. As you can see in the output, the database version displayed is Oracle AI Database 26ai. Now let's begin our SQL Firewall configuration. Our first step is creating a dedicated administrator account called DBAJUNCTION. This account will be responsible for managing SQL Firewall policies and administration. After creating the user, we grant the required privileges, including the SQL Firewall Administrator role, and enable REST access along with schema sharing capabilities. Since this is a demonstration environment, we'll allocate a quota of 100 megabytes to the DBAJUNCTION user. Later, we'll provide unlimited quota to our application user app26ai. In a production environment, however, quota allocation should always be determined according to your storage requirements and organizational standards. Next, we create our application user, app26ai. This user represents the business application that we'll be monitoring and protecting using SQL Firewall. After granting the required privileges and assigning the appropriate quota, our initial environment setup is complete. Now let's log in as the DBAJUNCTION user. Before proceeding, we'll execute the show user command to verify that we're connected using the correct account. Our next step is to verify the current status of SQL Firewall by querying the DBA SQL Firewall status view. At this point, we can see that SQL Firewall has not yet been enabled. Let's enable SQL Firewall by executing the dbms SQL Firewall.enable procedure. Once the command completes successfully, we'll query the same status view again to confirm that SQL Firewall is now active. With SQL Firewall enabled, we can move to the learning phase for our application user app26ai. During the learning phase, SQL Firewall observes normal application activity and learns which SQL statements should be considered trusted. We'll now start capturing SQL activity for our app26ai application user. Once the capture process starts successfully, SQL Firewall begins recording authorized SQL operations executed by the application. Now let's log in as our application user app26ai. We'll verify the connected user using the show user command. Since this is a demonstration environment and we want to save some time, we have already prepared all the required SQL statements. Before creating our objects, we'll first check and remove any existing employees and departments tables to avoid conflicts from previous executions. Next, we'll create our employees and departments tables. Once the tables are created successfully, we'll populate them with sample business data and commit the changes. Now let's execute a few normal application queries. We can see the results directly in the script output window. These operations represent legitimate application behavior and will therefore be captured by SQL Firewall as trusted SQL activity. During this learning phase, Oracle continuously records authorized SQL statements and builds a security baseline for the application. This baseline later becomes the foundation for the SQL Firewall allow list, enabling Oracle to distinguish between legitimate and unauthorized SQL activity. Now that we've completed our application workload simulation, let's switch back to our DBAJUNCTION administrator account. The next step is to stop the SQL capture process for our app26ai application user. We'll execute the dbms SQL Firewall.stop capture procedure and ensure that it completes successfully without any errors. At this point, SQL Firewall has successfully learned the normal behavior of our application. Now let's review the SQL statements that were captured during the learning phase. As you can see, there are multiple entries recorded in the capture logs. What's interesting here is that Oracle AI Database 26ai not only captured our application's SQL statements, but also recorded additional interactions performed during the session. This demonstrates how SQL Firewall continuously observes and learns the behavior of the application environment before enforcement is enabled. The next step is generating our SQL allow list. This allow list becomes the trusted baseline for the application. In other words, once enforcement is enabled, only SQL statements that exist in this allow list will be permitted to execute. We'll now execute the generate allow list procedure for our App26ai user. Once the allow list has been generated successfully, we can proceed to enable SQL Firewall enforcement mode. By enabling enforcement mode with the block parameter set to true, Oracle will immediately block any SQL statement that does not match the approved allow list. At this point, SQL Firewall transitions from learning mode into active protection mode. Let's verify that our allow list has been generated successfully. As we have seen, the SQL statements captured during the learning phase are now part of our approved allow list. Everything looks good, and our environment is now protected by SQL Firewall. Now comes the most important part of this demonstration. Let's switch back to our application user, App26ai. For demonstration, we are using Oracle Live Labs. Before attempting any unauthorized activity, let's first execute a SQL statement that already exists in our allow list. For example, select star from departments. As expected, the query executes successfully because it matches one of the trusted SQL statements captured during the learning phase. Now let's attempt to execute a SQL statement that was never captured before. In this example, we'll attempt to drop the departments table. And there it is. Oracle SQL Firewall immediately blocks the operation, because this SQL statement does not exist in the approved allow list. We can clearly observe the SQL Firewall violation error in the script output window. This is exactly how Oracle SQL Firewall protects applications from unauthorized SQL execution and potential SQL injection attacks. Instead of trying to identify every possible malicious statement, the allow list approach ensures that only known, safe SQL statements are allowed to run. This provides a powerful layer of protection against potential threats and makes sure that your database environment is secure. Oracle simply permits only known and trusted SQL behavior. To further validate this behavior, let's execute another SQL statement that exists in our allow list. As expected, the operation executes successfully, confirming that SQL Firewall is allowing trusted SQL while blocking everything else.
That's all for today's Oracle Deep Dive. At DBAJUNCTION, we turn complex Oracle technologies into practical knowledge. Thanks for watching. I'll see you in the next DBAJUNCTION session.